Hi everyone, I'm Whit Roy. Today I've invited an electrical tutor and an apprentice to have a conversation as they go through topics from the EWRB Electrician Theory exam. I hope you enjoy this style of learning.
All right, Sarah. Today we're continuing with topic 14, electrical safety, personal safety. This topic is really about how electricity affects the human body and how we keep ourselves and others safe when we're working.
Yeah, I know this one's important. It feels like it's less maths and more real-life stuff.
Exactly. And it's the stuff that can seriously hurt or kill you if it's ignored. Let's start with electric shock. Electric shock happens when current flows through the body along a path.
So it's not just touching something live?
No, you need a complete path. Common paths are hand to hand or hand to foot. Once your body becomes part of the circuit, current flows through you.
And that's what causes the injury?
Yes, the severity depends on a few things. Current level is one, time and contact is another. Skin condition matters too, like whether it's wet or dry.
Why does wet skin make it worse?
Because moisture lowers resistance. Lower resistance allows more current to flow. More current means more damage.
So even normal household voltage can be dangerous?
Absolutely. Even small currents can be fatal under the right conditions, especially if the current passes through the heart.
That's the heart rhythm problem you mentioned before?
Yes, electricity can interfere with the heart's electrical signals and cause ventricular fibrillation. That's often fatal if not treated immediately.
That's pretty serious.
It is. That's why we never treat electricity casually. Now, peak voltage also matters.
What does peak voltage mean?
Peak voltage stresses insulation more than RMS voltage. Higher peak voltage increases the chance of insulation failure and shock.
So insulation condition matters too?
Very much. Damaged insulation, cuts in cables or worn equipment increase the risk of shock.
Okay, so how do we stop that risk?
We use isolation. Isolation removes the electrical energy so the circuit cannot be energized while work is being done.
Is switching off the same as isolation?
No, switching off alone isn't safe. Someone could turn it back on. Isolation means physically disconnecting the supply and securing it.
That's where lock-off comes in.
Correct. Locking off means securing the isolator in the off position using a lock so it cannot be operated.
And the tag goes with that.
Yes, a safety tag is attached to the isolator. It shows who isolated it, when and why. It warns others not to operate it.
So the tag is about communication.
Exactly. Tags improve communication on site and reduce accidental energization.
But the tag alone doesn't physically stop it.
Right. A tag by itself does not prevent operation. Wherever possible, lock and tag together.
Got it.
Now, after isolation, we still don't touch anything until we've proven it did.
That's the prove, test, prove rule?
Yes. First, you prove your tester on a known live source. Second, you test the circuit to confirm it's dead. Third, you prove the tester again.
Why do we prove the tester again?
Because the tester could fail during testing. Proving again confirms the meter still works.
So a zero reading alone isn't enough.
Never trust a zero reading unless you've followed prove, test, prove.
Okay.
Now, let's talk about isolation procedures more broadly. Isolation removes the risk of electric shock and stops unexpected movement of machinery.
Like motors starting up.
Exactly. Unexpected startup can be just as dangerous as electric shock.
That makes sense.
Written isolation procedures are important too.
Why written procedures?
They ensure consistency and legal compliance. They describe identifying energy sources, isolating, locking off, tagging, testing dead, carrying out work, and restoring power safely.
So it's a full process, not just one step.
Correct. Skipping steps leads to accidents.
What about safety tags again? Are there rules for removing them?
Yes, usually only the person who applied the tag may remove it, unless a supervisor authorizes removal.
That stops someone else making a mistake.
Exactly. Now let's move into responsibilities under the law.
That's under the Health and Safety at Work Act?
Yes, employers, or PCBUs, must provide safe equipment, tools, PPE, training, supervision, and manage hazards and risks.
And employees?
Employees must take reasonable care of their own safety, not put others at risk, follow procedures, and use PPE provided.
So both sides have duties.
Correct. Safety is shared.
What about day-to-day safety practices?
That's safe working practices. You must always look for hazards and act to eliminate, isolate, or minimize risks.
What kinds of hazards?
Electrical hazards, height hazards, moving machinery, poor access, poor lighting, wet conditions, and so on.
So before starting work, we check the site?
Yes, preliminary safety checks include assessing the site, identifying hazards, checking ladders and scaffolding, and ensuring tools and PPE are suitable.
What happens if we don't do that?
Accidents happen. Many injuries occur before work even begins.
Okay.
Now, tools and equipment must be fit for purpose and in good condition.
That includes insulated tools.
Yes, insulated tools reduce the chance of current traveling through the tool into the user.
And PPE.
PPE includes gloves, eye protection, mats, safety harnesses, and arc-rated clothing where required. PPE must be maintained and replaced when worn.
What about regular checks?
Tools and PPE must be checked regularly. Faulty equipment must be repaired or removed from service immediately.
That makes sense.
Now let's talk about damp or outdoor conditions.
That's higher risk, right?
Yes, moisture lowers body resistance and increases shock risk. In these situations, you use RCD protection or isolating transformers.
So extra protection layers.
Exactly.
What about ladders?
Metal ladders conduct electricity and increase shock risk. Use fiberglass ladders near live equipment.
And housekeeping?
A tidy work area prevents slips, trips, falls, and fire hazards. It also shows professionalism.
Now fires. Electrical fires are different?
Yes, for electrical fires, use dry powder or CO2 extinguishers only.
Never water or foam?
Correct. Water and foam conduct electricity and can make things worse.
What if someone is stuck on live equipment?
Do not touch them unless the power is isolated. Isolate the supply first. If needed, use a dry, non-conductive object to separate them, then provide first aid or CPR once safe.
That's intense.
It is. That's why training is critical.
What about stored energy, like capacitors?
Capacitors can stay charged even after the power is switched off. They must be treated as live until proven safe.
So isolate and wait?
Yes, isolate and lock off, prove, test the capacitor terminals, and wait the required discharge time.
And never short it with a tool?
Never. Use the correct discharge method.
Okay.
High voltage work is another area.
That's only for authorized people?
Correct. High voltage work involves risks like arcing, step and touch potentials, and clearance distances. Written approval is required.
So no casual high voltage work?
None at all.
What about short circuits?
Short circuits create extremely high fault currents. They can cause arc flash, fire, and explosive force.
That's why PPE matters.
Yes, proper protection and procedures reduce injury risk.
And explosive atmospheres?
Any spark can ignite flammable gases or vapors. Equipment must be isolated and confirmed dead, and only X-rated gear used where required.
This topic covers a lot.
It does, because safety is everywhere.
One more thing, sometimes a second competent person is required.
When is that?
When risk is high or live testing is needed, they assist in emergencies and ensure procedures are followed.
So you're never completely alone.
Exactly.
I can see how this connects to the exam now.
It does, but more importantly, it connects to real life. These rules exist because people have been seriously injured or killed when safety steps were skipped.
That puts it into perspective.
Exactly. And this isn't just theory either. The Electrical Workers Registration Board recently reported a real case where someone was doing electrical work at a family member's house and cut a neutral cable. That created a serious risk of fatal electric shock. The person was prosecuted, fined, and had to pay court costs. It shows how dangerous even small jobs can be if isolation and testing aren't done properly.
Wow, yeah, that makes it feel very real.
It does. That's why things like isolation, lock-off, safety tags, and the prove, test, prove method matter every single time, even when the job looks simple.
I get it now. It's not about rushing or assuming, it's about following the process.
That's right. Electrical safety isn't about fear, it's about control and discipline.
Thanks, Mark. This explanation helped a lot.
No worries. Just keep reviewing it slowly. Safety knowledge builds over time.
All right, thanks again.
Take care.